Salutations and welcome to lecture. This video is going to take a look at the fluid connective tissue of the cardiovascular system, blood. We will start off with a general overview of the function and composition of blood. Blood is a fluid connective tissue responsible for three functions: transportation, defense, and maintaining homeostasis. Up first, transportation. You might consider this the primary function of blood. Nutrients like glucose, gases like oxygen and carbon dioxide, and waste all travel throughout the body using blood as their transportation medium. Blood makes an excellent transportation system with access to almost every tissue in the human body and rapid flow throughout the cardiovascular system. This allows for complete and speedy delivery. Spectacular! Blood also helps defend the body against infection and pathogens. Lymphocytes, or white blood cells, are key to the body's immune defense system, and platelets help with clotting to seal off damaged blood vessels and prevent hemorrhage. Finally, blood helps maintain homeostasis. By increasing or decreasing blood flow to the periphery, the body can cool or warm itself respectively to control body temperature. Blood also helps maintain homeostasis of the body's pH as well as chemical and water balance in cells. So what makes up this magical transportation medium? There are two main components to blood: plasma and formed elements. As shown here, these two components easily separate once a blood sample is put into a centrifuge and spun to cause the formed elements to sink and the plasma to rise. Plasma is the fluid portion of the blood and is made of 90% water. The formed elements include blood cells known as erythrocytes or red blood cells, leukocytes or white blood cells, and cell fragments known as platelets. Blood also contains plasma proteins and other dissolved substances like glucose, lipids, and electrolytes, as well as some dissolved gases. We will now explore the formed elements in more detail. Yay! Erythrocytes are your red blood cells. If it helps, erythro means red and cyte means cell. They are literally named your red cells. Erythrocytes are the most abundant formed element in blood. They're everywhere. In fact, they're what give blood its characteristic red color. Abundant red blood cells is a good thing because they are responsible for transporting oxygen and some carbon dioxide to and from the lungs and tissues. That's an important job. Hemoglobin is the oxygen-carrying compound in the red blood cells. There are 4 hemoglobin molecules per cell. Each hemoglobin is made up of 4 globin proteins and 1 heme group. The heme group contains iron. Red blood cells are fluffy biconcave discs that bounce around inside your blood vessels as they move about transporting oxygen. This shape is important because it helps keep them moving without getting stuck. It also increases surface area to facilitate gas exchange. Clever. Of note, mature red blood cells have no nucleus and no organelles. In fact, once the red blood cell hits the eject button on the nucleus and organelles, the void in contents causes the cell to cave in on itself in the middle, thus forming the characteristic biconcave disc. But wait, how do they divide with no nucleus and no organelles? They don't. Red blood cells live for about 4 months or 120 days before being phagocytized by macrophages and having their parts recycled. Never fear, the red bone marrow is busy making more. A shortage of red blood cells causes a class of diseases known as anemia. While there are many different kinds of anemia, sickle cell anemia and iron deficiency anemia are perhaps the most well known. In sickle cell anemia, the red blood cells sickle or form a crescent shape when they give up their oxygen to the tissues. This loss of their fluffy biconcave disc shape causes them to get stuck in the smaller blood vessels, thus cutting off blood flow to the tissue and causing what is known as a sickle cell crisis. Very painful. In iron deficiency anemia, a deficiency of dietary iron limits the ability of the body to make the heme necessary for red blood cell production. This is the most common form of anemia. Need a good source of dietary iron? Try liver. No thanks to liver? Me either. How about broccoli? Much better. Unlike erythrocytes, leukocytes, or white blood cells, are complete cells. That means they come with a nucleus and organelles. White blood cells are used for the body's defense. On guard! Leukocytes defend the body against pathogens like bacteria, viruses, parasites, and tumor cells, and use a process known as diapedesis to slip in and out of blood vessels to do their job. Of note, white blood cells have a much shorter lifespan than red blood cells and can die in as little as a few hours or days. However, the number of leukocytes can also be doubled in a matter of hours in response to injury or infection. This increase in the number of white blood cells is known as leukocytosis and can indicate the presence of an infection or disease. There are both granular and agranular types of white blood cells. Granular leukocytes include neutrophils, which eat foreign invaders like bacteria and fungi, eosinophils, which attack and digest parasitic worms, and basophils, which contain histamines as part of the inflammatory response. Agranular leukocytes include monocytes, which are large macrophages used to fight chronic infections. Monocytes can also activate the lymphocytes or other class of agranulocytes. About 20 to 30% of all leukocytes are lymphocytes and are used to mount defenses against specific pathogens. Perhaps you have heard of leukemia or lymphoma. These cancers both involve the leukocytes. The final formed elements in the blood are the platelets. Although they are sometimes referred to as thrombocytes, this is an inaccurate misnomer as platelets are not cells, but rather cell fragments. Just like erythrocytes, platelets are incomplete cells. Platelets are actually little fragments or broken pieces off of a large cell known as a megakaryocyte. Like little fingernail clippings, they break off of this large cell as irregularly shaped fragments with jagged edges. Unlike erythrocytes, platelets are designed to get caught in the blood vessels and cause a clot. The formation of blood clots is key to helping seal off damaged blood vessels and prevent additional blood loss or hemorrhage. If you've ever skinned your knee or cut your finger, you know the importance of platelets forming the clot to seal off the wound. The spleen serves as a storage facility for your platelets while others are circulating and ready to help with hemostasis, or the process of stopping the flow of blood. And now for our anatomical analogy. To what shall I compare the platelets? Shall I compare them to an apple or a steak? No! Platelets are like the little leftover food particles from washing your dinner dishes that clog up the drain. Irregularly shaped, slightly unattractive, majorly creepy to touch when you have to clean out the sink. They clog up the drain and prevent the dirty dishwasher from leaving the sink, just like platelets clog up the hole in the damaged blood vessel and prevent blood from leaving the circulatory system. Ta-da! Platelets. We will finish today with a look at hemostasis. The process of stopping a flow of blood is known as hemostasis. This usually refers to the body's efforts to avoid hemorrhage or massive blood loss after injury. There are three parts to hemostasis. First, the blood vessels will constrict to attempt to minimize blood flow through the damaged vessel and therefore minimize blood loss. This part is known as vascular spasm. Secondly, a platelet plug will form to seal off the damaged area. Finally, coagulation, or the process of blood thickening, will occur to again minimize blood loss and promote the formation of a fibrin clot. Fibrinolysis refers to the dissolving of that same fibrin clot in a healing blood vessel when it is no longer needed. We finished today by looking at a few clotting disorders. You may have heard of hemophilia, particularly if you've studied your European history. This disorder ran rampant in the royal families and ended many a royal life from genetic inbreeding. In this case, trying to preserve the royal blood worked against them by propagating a blood disorder. Hemophilia results from an inadequate production of clotting factors and results in excessive bleeding from typically minor injuries like a cut or a bloody nose. These relatively normal injuries to blood vessels can become life-threatening hemorrhages in people with hemophilia. The opposite of hemophilia is thrombophilia. Thrombophilia is when your blood forms clots too easily. These clots can cause major issues by blocking blood flow through the blood vessels. In thrombophilia, clots tend to form too frequently and at inappropriate times, aka not in response to injury. It is important to understand the difference between a thrombus and an embolus. A thrombus is a clot that is formed in the lining of a blood vessel. An embolus is a thrombus that has broken free and is now circulating in the bloodstream. A pulmonary embolism is an embolus that has traveled to the lungs and gotten lodged in the pulmonary blood vessels. This essentially cuts off blood flow to part of the lung. Symptoms include shortness of breath, chest pain, cough, and low blood oxygen levels, and can be a life-threatening situation. Seek emergency medical attention immediately. The sooner you get treatment, the better chance of an improved outcome. Well, that does it for the blood. See you next time.